Okay, today we're going to look at Lesson 20, and your I can statement or learning objective is I can add and subtract rational expressions. So we're continuing on with our work of rational expressions. Today we're going to add and subtract. And so remember, our rational expressions are written as fractions where you have a polynomial on the top and a polynomial on the bottom. Okay, so we're going to add and subtract those today. Remember, I'm going to be moving faster in the video than I would be if we were in person, so feel free to pause, rewind, watch it at your own pace, do what you need to do. Okay. Now, before we get started, I will make a disclaimer. These notes are gonna be a little bit different than normal. Okay. As we're adding and subtracting these expressions, there's not really a list of steps that I can give you or a real definite list of directions. So what we're gonna do is I'm going to work out some examples that go very, very closely with your Math Excel problems. I can even tell you which numbers on your homework are similar to the examples, and I'm going to work those out, and I'm going to talk you through them. So I'm going to explain why I'm doing what I'm doing and my thought process behind it, behind each step that I make, and I would like you to follow along with me. It will be helpful if you will write these examples down and go along with me throughout the video, just so you can get some practice and you can kind of get some understanding of what we're doing. And because these problems are kind of like a puzzle, and you're not going to do every single one exactly the same way. So practicing and seeing the variety is going to be very helpful to you. All right, so let's go ahead and get started. So the first thing that we need to make a note of is in order to add or subtract fractions, you must have common or like denominators. Okay, so for example, if I have 3/5 plus 1/5, those have the same denominator, so I can do that addition straight across. So 3 plus 1 is 4, and that's over 5. Okay. However, sometimes you get things like this. So 3/5 plus 1/4. Now, those denominators are not the same, so we can't just add straight across like we want to. All right, we have to make these denominators the same. And there are a couple different ways you can do it. You can try to find the least common multiple and go from there. But what I like to do is something that always works. We're just going to crisscross the denominators, the 4 and the 5. So I'm going to multiply this side by 4 over 4 and this side by 5 over 5. Those expressions are equal to 1, and so that's why we can multiply them, because that's the same as multiplying by 1, and we know that 1 doesn't change anything, okay? So we can change this fraction to 12 over 20. We can change this one to 5 over 20. Then, and just to show you how this is working, because we're going to need to do it with our rational expressions, you have 12 plus 5 all over 20. And that simplifies to 17 over 20. Okay, so that's the same kind of process that we're going to do today. Some of our problems are going to have like denominators, so we're just going to go straight across. Sometimes they're not going to be alike, so we're going to have to multiply each side by a quantity representing 1. Then when they have like denominators, you can squish them together and then add, subtract, and simplify. Okay? So hopefully you remember doing that. Hopefully you're familiar with adding and subtracting just numerical fractions. And so we'll get started with our rational expressions. Okay, here's example number 1. We have 2y plus 2 over y minus 6 plus 2y plus 9 over y minus 6. So here our denominators are the same, so we can just go straight across. So we have y minus 6 on the bottom. On the top, we're going to have 2y plus 2 plus 2y plus 9. Okay. Now, we have like terms on the top, so we can simplify that. So 2y plus 2y is 4y. 2 plus 9 is 11. And then on the bottom, I have y minus 6. Okay, I'm going to go ahead, before I look to see if I can simplify, I'm going to go ahead and tell you the restricted values. So y cannot equal 6. Okay, now, after I have combined like terms, before you determine if this is your final answer or not, you need to think about if you could factor either of those expressions, if you could pull out a GCF or anything like that. So y minus 6 on the bottom, there's really nothing we can do there. 4y plus 11. 4 and 11, they don't have a GCF other than 1. There's only one y. If we tried to factor that, we couldn't, and there would be nothing we could do. So that is just going to be our simplified answer. So 4y plus 11 over y minus 6, and our restricted values are, or our restricted value is 6. So y cannot equal 6. And I just realized I should have skipped a line so that all this didn't get jumbled. So I'm just drawing a little line there to help us keep everything organized. So I do apologize. I don't mean for that to be all squished together. But hopefully on your notes you can space it out a little better. Okay, here's number 2. We have 5x minus 22 over x minus 5 minus x minus 2 over x minus 5. So again here, our denominators match. So we're good to go. We can just bring that over. But on the top, we have some things that we can combine. So we have 5x minus 22. Now, here's something that's tricky. When you're subtracting, we're subtracting this entire quantity, okay? So there's a couple different ways you can do that. You can do minus parentheses, x minus 2, or you can go ahead and distribute that negative and then write it down. Or you can think minus x minus a negative 2, and that'll get you to the same place. I'm working it out completely just to show you what we're doing here. But just know there are a couple different ways you can do that. All right. And then some of you might even be able to do it in your head. You can do 5x minus x and then negative 22 minus a negative 2. That can cut out some steps as well. All right. But like I said, I'm going to work it out completely. So I'm just going to scoot down here. So 5x minus 22 minus x plus 2 all over x minus 5. Okay, combine our like terms. 5x minus x is 4x. Negative 22 plus 2 is negative 20. On the bottom, I have x minus 5. Okay, before I move on, I'm going to pick out my restricted values. So I know that x cannot equal 5. Okay, now, before I'm going to decide if this is my final answer, I need to see if anything will factor. So x minus 5, that's as low as it can go. 4x and negative 20, those have a GCF. So let's see, the GCF of 4 and 20 is 4. That leaves me with x minus 5 in parentheses, and I have x minus 5 on the bottom. Now I can simplify like we've been doing the past couple days. X minus 5 over x minus 5 divides out, and we're just left with a 4. So our simplified expression is just a 4. Okay? Okay, we're going to do one more example where the denominators are the same. So our denominators match, so we're good to go. So I'm going to come over here. I'm going to bring that denominator over. So x squared minus x minus 6. Now, on the top, I have x squared minus 4x, and then I'm subtracting the quantity x minus 6. Okay? And actually, I'm going to scoot that over here just so I have more space. So on the top, I have x squared minus 4x minus x plus 6. And on the bottom, I have x squared minus x minus 6. On the top, I can simplify. So x squared minus 5x plus 6. And then on the bottom, x squared minus x minus 6. Now, I don't have factors on the bottom. I have a quadratic expression, so I don't know what my restricted values are yet. So this one's a little bit different, and I'm actually going to need to factor both expressions before I can do anything else. So on the top, we're going to have two factors. We need x and x. Then we need factors of 6 that add to give us 5, a negative 5. So that's going to be a negative 2 and a negative 3, okay, because negative 2 times negative 3 is 6, and if you add those, you get negative 5. Then on the bottom, we're going to need two factors. We have x and x. This time, we have to multiply to get negative 6 and add to get negative 1. So that's going to be negative 3, positive 2. So negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Okay, and if you're struggling with factoring, you can always go back and practice factoring. You can always go to the side. You can do the star method or factor by grouping, or you can list out the factors and find the pair that adds, whatever you need to do. But at this point, I do expect you to be able to factor pretty well and pretty quickly. So that's why I'm not working that out separately. Okay. Now, I have factors on the bottom, so I can tell you my restricted values. X cannot be 3 or negative 2. Okay. Now, can I simplify anything? I have x minus 3 over x minus 3, and so I'm left with x minus 2 over x plus 2. And that is as simplified as it can go. Okay, next we have 7 over x minus 4 plus 6 over x plus 3. Obviously here our two denominators do not match. So we're going to swap denominators, kind of, and multiply by quantities equaling 1. So in this side, I'm going to do x minus 4 over x minus 4. So that's what I'm multiplying on the top and the bottom. On this side, and I didn't think, I should have wrote that number somewhere different so I would have space, but I'm going to do x plus 3 over x plus 3. So both of those quantities are equal to 1, just like we did with our numerical fractions earlier. We're doing the same thing here, okay? So now we're going to make a new problem. So we have 7 times the quantity x plus 3 plus 6 times the quantity x minus 4 all over x minus 4 times the quantity x plus 3. Now, okay, I wrote it out this way so you could see everything that's happening. Again, you could skip some of this. You can go ahead and distribute, so 7x plus 21, 6x minus 24, and go ahead and put those up there. Simplified, and then combine like terms. That'll save you some steps. But I wanted to show you this to make a point. Okay, I know that here it's tempting to cancel out the x plus 3s and the x minus 4s, but you cannot do that because these are separated by addition. If this was multiplication, it would be fair game. You could go ahead and mark those out. But you cannot divide them out through addition. Okay, the addition says that this quantity, it's this quantity plus this quantity over this. Okay, they do not divide out. So if you write it out like that, no, you cannot cancel or cannot divide out at this point. Okay, you have to distribute. So like I said before, that's going to be 7x plus 21, and then 6x minus 24, all over the quantity x minus 4 times the quantity x plus 3. All right, now I can combine like terms. So 7x and 6x is 13x. 21 minus 24 is negative 3. And then on the bottom, I have the quantity x minus 4 and then x plus 3. All right, now I can find my restricted values because I have nice factors down here. So I know that I'm getting my variables all mixed up here. X cannot equal 4 or negative 3. All right. Can we factor anything? 13 and negative 3. There's not a GCF. There's only one x. So this cannot go any farther. So we leave it as is. So 13x minus 3 over the quantity x minus 4 times the quantity x plus 3. Okay, here's example number 5. We have 9 divided by the quantity x plus 8 minus 9 divided by x. Okay, so our denominators do not match, so we're going to kind of crisscross those. On this side, we're going to multiply by x over x. On this side, we're going to do x plus 8 over x plus 8. All right, now we can multiply those and create our new expression over here. So we have 9x minus 9 times the quantity x plus 8 over x times the quantity x plus 8. And again, or you could rewrite it either way. Just know that order doesn't matter there on the bottom. All right, I know it's tempting to mark these out, but you can't. You have to distribute and simplify first. Okay, so I have 9x and then minus 9x and then negative 72. And then on the bottom, I have x, the quantity x plus 8. Let's see, I can simplify. 9x minus 9x cancels out, and I'm left with negative 72 over x times the quantity x plus 8. I have my nice two factors, so I can tell you my restricted values. X cannot equal 0 or negative 8. And there's nothing to factor on the top, so we can just leave it like this. And that is our simplified expression. Okay, so very similar to number 4, just a little bit easier, a little bit less work to do. Okay, number 6, we have x minus 7 over x plus 7 plus x plus 7 over x minus 7. These are very similar, and so this is going to require us to pay close attention to what we're doing and make sure we write down the correct signs and we keep track of our steps here. Okay. So these are not the same. They're very, very close, but not the same. So we have to do that crisscross. So on this side, I'll have x minus 7 over x minus 7. On this side, I'll do x plus 7 over x plus 7. Okay. Now, that's going to turn into the quantity x minus 7 squared, and I'm doing that because x minus 7 and x minus 7, it's squared. You could write it out as two binomials if you want to. I'm just trying to save some space, save myself some work, and write it this way. Plus, on this side, it's x plus 7 squared. Okay, and again, you could write that out as two binomials as well. And then on the bottom, we have x plus 7 and x minus 7. All right, now, again, I know it's tempting to cancel, but we can't because we have this addition in the middle, okay? So, in order to see what we can do here, we're going to expand this, and see what happens, okay? So, you can either do the FOIL method, double distributive property, or if you remember the shortcut, that's what I'm going to use. So, when you have a binomial squared, you do the first term squared, and then it's minus, so minus 2 times x times 7. So that's negative 14x. And then negative 7 squared is positive 49. Okay, again, that works because it's squaring a binomial. All right, then plus, we're going to do the same thing here. And it's going to be the exact same, except instead of negative, it's positive. So x squared plus 14x plus 49. All over x plus 7 times x minus 7. Okay, so now on top, x squared and x squared is 2x squared. Negative 14x and 14x cancel. 49 and 49 is 98. And then I have x plus 7 and x minus 7 on the bottom. Okay, now, I can pick out my restricted values really easily here. So x cannot equal 7 or negative 7. Okay. To see if I need to simplify any more, on top, 2 and 98, they do have a GCF of 2. But if I take the GCF out, if I take a 2 out, that's just going to give me x squared plus 49. And that's still not going to let me cancel out anything. And so I can really just stop here. So when you're trying to decide if you can simplify, if you're looking at to decide if you need to factor or what needs to happen here, if factoring will not help you divide or mark something out, there's no point in it, okay? So the only reason we would factor something back out is to see if we can simplify. So I know that taking a 2 out is not going to simplify with anything, so I'm just going to leave it as is. Okay, our last 3 examples and your last 3 problems in Math Excel are going to be a little bit different, okay? So you're going to be given a rational expression divided by another rational expression, and you're still going to have to do the adding and subtracting to get this in the right form. But then once you get it here, there's a little shortcut to figure out how it simplifies. You do A times D, so the top and bottom, over B times C. And so that's the same as doing that keep, change, flip that we did yesterday. This is just a little shortcut. So when we get it as simplified as we can with adding and subtracting, we'll put it back in this form. We'll do AD over BC and go from there. So an example of that would be if I gave you 2/3 divided by 4. All right, 4 is a whole number, so we'll put 1 under it. And so we'll do AD minus B or over BC. So AD is 2. BC is 3 times 4 is 12. 2 over 12 is 1/6. Okay, so that's a quick, easy way to simplify that. So we do have 3 problems thrown here on the end that require us to add and subtract the rational expressions and then use this little shortcut. Okay, so that's what we're going to do for the remaining 3 problems. Okay, so number 7, we have 2 plus 7/9 over 5 minus 1/4. So we're going to use what we've been doing to simplify the top, then we'll simplify the bottom and go on. So we have 2 plus 7 over 9. All right, this is the same as 2 over 1. All right, we need to make these match. So I can do this side by 1 over 1, which doesn't change anything. This side is 9 over 9. Okay, so that gives me 18 over 9 plus 7 over 9. And I can just go straight across. So 18 plus 7 is 25. So that gives me 25 over 9. So that's the top. Now I'm going to do the bottom. So 5 over 1 minus 1/4. Again, if I multiply by 1, we saw it didn't do anything. So I'll just do this side by 4 over 4. Okay, so that gives me 20 over 4 minus 1 over 4. That gives me 19/4. Now, I've got this top simplified in the bottom. We're going to go back to this form. So 25 over 9 divided by 19 over 4. Okay, so I'm going to do the outsides. So 25 times 4 over the insides, 9 times 19. And that gives me 100 over 171. That cannot simplify. So that's my final answer. Okay, now I know that's a lot, but we're using the same skills that we've been doing, okay, and then we're just putting it in a different form and simplifying from there using that little shortcut. Okay, here's example number 8. We have 1 over x minus 2 divided by 1 minus 1 over x minus 2. So the top is already in that form. We already have the A, B, okay? It's already ready to go. We need to get this bottom part together. So 1 minus 1 over x minus 2. All right. If we multiply this side by 1 over 1, it's not going to do anything. So over here, I need to do x minus 2 over x minus 2. Okay. So it's going to give me x minus 2. And then minus 1 all over x minus 2. We can simplify. So x minus 3 over x minus 2. Now we can put this back in the correct form. So we've got 1 over x minus 2 all over x minus 3 or divided by x minus 3 over x minus 2. All right, so we're going to do outsides. So that's x minus 2. We're going to do insides, x minus 2 and x minus 3. Now, can we simplify here? Yes, we can mark out the x minus 2's. So it leaves us with 1 over x minus 3. And that is our final answer, our most simplified rational expression. Okay, here's number 9. It's our last example. And I'm going to try to fit it all on this last little bit of my page. So we'll see how I do. All right, so on the top we have 3 over w plus 5 over x. Then on the bottom, we're dividing by 5 over w minus 3 over x. So we're going to take each of these and get them simplified. So 3 over w plus 5 over x. Okay, these are not the same, so we're going to do that crisscross. So x over x here, w over w there, and that gives us 3x plus 5w all over xw. Okay? And there is nothing else we can simplify. I know it's tempting to mark those out, but we can't, so we leave this one as is. Now we'll do the bottom here. So 5 over w minus 3 over x. On this side we'll do x over x, and this one we'll do w over w. And that gives us 5x minus 3w all over w, or xw, or wx, whatever you want to say. Now, I have these in this nice order here, so I'm going to go ahead. I'm not going to write it again just because it worked out so nicely that these fit right over one another. All right, so I'm going to do outsides and insides. Okay, so I'm going to come down here. So on the outside, I have 3x plus 5w times xw. All right, on the bottom, I have xw times 5x minus 3w. Can I simplify anything? Yep, the xw's can go away, and we're left with 3x plus 5w all over 5x minus 3w. And I know that it's very, very tempting here to try to cancel something out or divide something out, but there's nothing that we can do. This just is what it is. Okay, they're very, very similar, but they're different enough that nothing's going to cancel or divide out. All right, so that's your last example. I know that this has been a lot. We've done a lot of math, and these are really just going to take some practice on your part. You're really just going to have to work through them, use the math you know, and practice. We're going to spend a few days on this kind of stuff, so we're not rushing on to a new topic. We will take some time to practice this and go over it. So don't be overwhelmed. If you're having a hard time, that's okay. I would be happy to help you. You can always hop back in the Google Meet and ask questions, get help, hit Ask My Instructor, whatever you need. And a really great thing, or a really great way to get help, is if you get stuck on the homework, make a note of the problem, and then you can ask me about it in the next Google Meet, and I can go over it with the whole class. I'm happy to do that anytime. You just have to let me know that you need me. Now, I told you that I could tell you which problems these examples line up with in your homework, and I think actually I've got your homework set up so that the problems go right along with one another. We have a total of 10 problems in your Math Excel work, and we only did 9 examples, but one of your the extra problem is just one like these, where your denominator is the same. You're just adding or subtracting straight across. So I didn't think we needed an extra example of that, so that's why you have one more Math Excel problem than example. But they should line up very, very nicely, like example 1 should go with problem 1 in Math Excel, and example 2 should go with problem 2, and so on and so forth. Okay? And again, if you need help or have any questions, let me know. Have a great rest of your day.